Hello students, welcome to lecture 3B on separating mixtures. Let's first discuss how to separate mixtures, but before we get into that, let's discuss some notes. First off, if you have something like this NaClAq, what you should know is that that means that it's NaCl, the substance, and AQ means that's completely dissolved in water. Specifically, if it has AQ after, that means the substance can and will dissolve, and therefore, specifically, it will form an aqueous solution, also known as a homogeneous mixture. On the other hand, if you have something like CaSO4 solid, what that means is the S means it's insoluble generally, and obviously this symbol stands for calcium sulfate. So putting that together, you have insoluble calcium sulfate. If you have an S following something, that usually means that it cannot and will not dissolve a lot of the time, and therefore it will form a precipitate, which is a translucent solid that you really can't see much through. Okay? Now mixtures, as we know, are a physical combination of substances, meaning the substances, since they're combined physically, they can also be separated physically as well. For example, NaClAq, which is a homogeneous mixture, can be separated physically because it was combined physically to make it. Sand and water is also combined physically to make a sand-water mixture, so similarly, going backwards, it can also be separated physically. All right, and here are the methods of separation, which we'll go over in a minute. So now let's go over the first method for separating mixtures, which is filtration. Filtration generally separates heterogeneous solid-liquid mixtures, and the properties involved in filtration are solubility and size. Generally, what happens when you separate a heterogeneous mixture that's a solid-liquid mixture is that the large particles, the insoluble particles, and the solids generally will not pass through the filter because they're too large, and since they don't dissolve, they can't pass through. They will be stuck on filter paper right here. On the other hand, the smaller particles, the particles that are very soluble and can dissolve completely in water and form a solution, and liquids, all will pass through the filter relatively easily and go down through here. Okay, so let's try some examples here. First off, we have AgCl solid and LiClAq. If we interpret that, that means that we have AgCl, which is a precipitate, which cannot and will not dissolve, and LiClAq, which is an aqueous solution of LiCl, which is lithium chloride, that will completely dissolve. So what will happen is AgCl solid, which is a precipitate, would collect on the filter paper because it is insoluble and a solid, so it will stay in this filter paper right here. On the other hand, LiClAq, because it's an aqueous solution of lithium chloride that's dissolved, would pass through the filter due to its higher solubility and the fact that it is dissolved. Okay? So that's one example of a mixture that can be separated by filtration. Another example is a sand-water mixture, where the sand has larger particles and is a solid. Since sand is larger and is a solid, it would collect on the filter because it's too big to pass through and it's a solid, so it will not pass through the filter. All right, on the other hand, water, because it's a liquid, would pass through the filter. So the water would go down while the sand would stay on the filter paper. Okay, so make sure you understand filtration, where you separate based on solubility and size, and you separate heterogeneous solid-liquid mixtures. The large insoluble and solid particles will stay on the filter, while the smaller soluble particles and the liquids will pass through the filter easily. Okay, if you have AQ, it will pass through the filter relatively easily because it's soluble, while AgCl solid, for example, anything with S after it would collect on the filter because it's relatively insoluble and it's a solid. Okay, sand is obviously too big, so it will not pass through because of the particles and because it's solid, while water being a liquid will pass through. The second method for separating mixtures is called a separatory funnel, and a separatory funnel specifically will separate heterogeneous liquid-liquid mixtures that do not mix. All right, specifically, the properties involved in a separatory funnel are density and polarity. All right, the main one I want you to focus on here is density, however. Generally, what happens when you separate a heterogeneous liquid mixture that does not mix by separatory funnel, what happens is that there will be two layers formed since they don't mix. The less dense liquid will settle on the top that looks like this, while the more dense liquid will be on the bottom. And what will happen is that you can control the opening and closing of this thing called the stopcock, which is sort of like a lever which allows certain liquids to flow and certain liquids to not. And generally, you'll open it and separate it such that all of the more dense liquid pours through, and then you stop it immediately here so that all that's left is the less dense liquid. That's how you separate that, okay? An example of a mixture that can be separated using a separatory funnel is an oil-water mixture, where you allow them first to separate based on density. Specifically, water would settle to the bottom because it's more dense, while oil will remain on the top because it's less dense. So you could basically drain out water through the bottom while the oil would remain intact if the stopcock is turned before. Since oil is less dense than water is, it'll stay at the top, and if you turn the stopcock to stop the pouring, the liquid will settle out to whatever collection flask you're putting in, while the oil will remain in the separatory funnel. So you've separated that oil-water mixture, okay? Next, our next method for separating mixtures is distillation. Distillation separates homogeneous liquid-liquid and solid-liquid mixtures. So basically, if you have a homogeneous mixture of liquid-liquid or solid-solid, then you can separate it using distillation. The property used is boiling point for distillation. The summary of the results is as follows. The lower boiling point substance will generally evaporate first because of its lower boiling point, condense, and collect. So what it'll do is the lower boiling point material will evaporate up here into the fractionating column, go through here, and this condenser will actually put in water in and out to cool it down, and once it collects here, it'll collect back as a liquid. Okay? On the other hand, the higher boiling point materials will evaporate at a later time and or stay behind. One example of a homogeneous mixture that you can separate using distillation is NaCl-AQ. It's a solid-liquid mixture where you have NaCl being the solid and the liquid is water, obviously. So that you form NaCl-AQ or an aqueous solution, aka a homogeneous mixture of sodium chloride. So basically what happens is sodium chloride, since it has a higher boiling point, would be left behind, while water having a lower boiling point would evaporate, condense first, and collect in the condensation flask as a liquid, because NaCl's boiling point is much higher while water's is lower. Another example of a homogeneous mixture that you can separate that's a liquid-liquid mixture by distillation is C2H5OHAQ. This C2H5OH is ethanol, and obviously AQ implies that it completely dissolves in water, so the other liquid that's involved would be water. So put together you would form an aqueous solution or a homogeneous mixture of ethanol. So it's basically, you can think of it as a rubbing alcohol mixture, where the alcohol, having a lower boiling point than water, would evaporate, condense first, and collect in the condensation flask as a liquid first, because alcohol has a lower boiling point, while water would probably remain behind or evaporate later because it has a higher boiling point. Another example of a homogeneous mixture that can be separated by distillation is petroleum, where the mixture of compounds called hydrocarbons with hydrogen and carbon have the lower boiling point hydrocarbons evaporating, condensing, and collecting in the condensation flask as liquid first, just due to the fact that they have lower boiling points. While the other hydrocarbons, if you don't heat them to their boiling point, would stay behind. Okay? So that's how you would separate that. 3 examples there. Next, we have method 4 for separating mixtures, which is chromatography. Chromatography separates only ink mixtures. Specifically, it separates dye mixtures or ink dye mixtures. The properties involved in separating an ink mixture or an ink dye mixture by chromatography are solubility and polarity. Polarity, just for now, just think of it as attraction to the material in the column. Okay, and solubility is obviously the ability to dissolve. Generally, what happens when you separate an ink dye mixture by chromatography based on solubility and polarity is that the more polar and soluble materials will travel further up the column since they dissolve better in water and they're attracted better to the material in the column. So the more polar and soluble materials will dissolve better in water, attract more to the material in the column, and travel further up. While the less polar and less soluble materials will remain closer to the bottom. So for example, these green dyes are less soluble and less polar since they're closer to the bottom, while these red dyes, since they're closer to the top, would be more polar and more soluble. So these red dyes, in other words, would be more attracted to the material in the column and would dissolve better in, let's say, water if it was dissolved in it. While these green dyes would be less soluble in the medium water that is moving this stuff up, and also would be less attracted to the material in the column. All right? So an example of a mixture that can be separated by chromatography is pen ink, where it separates into colors with the more polar and more soluble components moving further up the column and the less soluble and less polar components remaining closer to the bottom. Okay? So the other methods for separation are twofold. The first type is magnets. Magnetism generally separates magnetic materials from non-magnetic materials. Specifically, the magnet will attract the magnetic materials, and what will stay behind are the non-magnetic materials. So make sure you write what I just said, that the magnetic materials will attract the magnet and move with the magnet away from the mixture, while the non-magnetic materials will remain behind. For example, iron and sulfur is an example of a heterogeneous mixture that you can separate based on the property of magnetism. The iron will attract to the magnet and travel away from the mixture, while sulfur will stay behind since it does not attract to the magnet. The last type of mixture that you can separate, the last method you can use to separate mixtures is centrifuge. which separates small solids and liquids by spinning them rapidly based on density. Specifically, more dense materials, you should write this down in your notes somewhere, would settle to the bottom. So just write, I'm going to write MG so you know that stands for more dense. You should write the full word there. More dense settles to the bottom, while the less dense, which I'm going to abbreviate LG, would probably be closer to the top, right? So an example of a mixture that be separated using a centrifuge is separating DNA from cell matter. Because DNA is more dense than a lot of cell matter, it would settle more to the bottom, while the other cell matter would probably be closer to the top because it's less dense, okay? So make sure that for each of the main four methods that you study the definition, meaning what mixtures it separates, the properties, the summary, and the examples. And then for these other two, just make sure you understand what the definitions and examples are, all right? So in addition to that, I just want you to, in addition to the notes, just make sure you answer these four questions, which are already in your practice problems packet. All right, that's it. See you tomorrow. Enjoy your afternoon. Bye-bye.